In this video, I'd like to talk about solving similar triangles where the problems are slightly more advanced. And with these problems, we're going to be finding some missing side length, in this case, x. And we're not explicitly told which triangles are similar, but we can figure this out. Since notice we have this triangle ABC and this bigger triangle ADE. And notice that they each have a right angle and they each share this angle here, A, which means that if we set up an equation, we could actually figure out that these two angles are equal as well, since we know that the three angles in a triangle add up to 180 degrees. If we called this angle X and this is 90, we would find that this is the same value in each of these, which we can call Y. So we can determine that this triangle ABC would be similar, let me rewrite that, to triangle ADE. And again, you need to be careful the way that you write these because the side lengths will correspond depending how it's written, how the letters are spelled out. So notice that AB corresponds to the side AD in the bigger triangle. And remember that with similar triangles, not only do they have three sets of equal angles, their side lengths are also proportional to each other. So if we figure out that proportionality, we can figure out this missing side length. And we can start by noticing that this side CB, which corresponds to ED, we know both of these measures here. And we can set up that ratio. We can say that ED divided by CB, this would give us our proportionality constant, which would be 8/6. And once we know that proportionality constant, we can use it to figure out x by comparing this side length AB to the side length AD. And let's do that. Since we can simplify this, this is just 4/3. And looking at the bigger side length on the bottom, that is AD, we will compare it to its corresponding side and the smaller of the two triangles, which is AB. And this is where it gets a little bit tricky, since notice that AD is really composed of AB and BD. So we have this length here, x, and we also add on this length of 8. So we can write AD as x plus 8, and then AB, that's just x. And we know that since the two triangles are similar, the proportionality constant is the same when we compare any of the corresponding sides, which means that this ratio is also equal to 4/3. And from here, we now have an equation where we can solve for x. And let me just make a little bit of room so that we can work on this. And let's first start by rewriting it. But the main idea is that we have x in the denominator. And to solve this for x, we need to get x out of the denominator. And to do that, we can just multiply each side by x. Since we know something divided by itself, that's just 1. So on the left-hand side, the x's will cancel out. And we get x plus 8 is equal to 4 times x divided by 3, or 4/3 x. And let's get rid of this other fraction. We can multiply both sides by 3, just so that we don't have any more fractions. And distributing this 3, we would get 3x plus 24. And on the right, we get just 4x, since the 3 divided by 3, that will just reduce to 1. And lastly, we want to get x on the same side of the equation, so let's subtract 3x. We can put it on the side where there are more x's so that we don't have to deal with a negative. And these cancel out. We get that 24 is equal to x. So this is what we think is the answer, but there is a way to check these. We think x is 24, but let's make sure this ratio makes sense, since we know that the bigger side divided by the smaller side, like we had here, simplifies to 4/3. And if we rewrite this AD over AB. The bigger side, AD, notice to go from A to B is 24, and then B to D, we add 8 more. So that makes AD 32, and AB is 24. And if we simplify this, divide each 32 and 24 by 8, we do get back 4/3, which means we can feel confident that this answer actually makes sense. And if we wanted to, we could actually figure out what AC and AE are, though we'd have to use the Pythagorean theorem. 6 squared plus 24 squared is equal to AC squared. We could simplify that and then use this proportionality constant or set up a ratio to figure out what AE, or namely what CE, would be equal to. But this problem isn't asking for that, and we can put our answer of 24 into our box here.